Students, good afternoon. Am I audible, Vishal? One of you can unmute and respond.
Yes, sir.
Yes, sir.
Fine, fine. So we'll just wait for another 2-3 minutes, okay? And we'll wait for your friends to join in, and then we'll start off. Okay. Uh, I welcome you all for this class for satellite communications. I think many of you will be knowing me. So I'll be handling batch 1 for satellite communications. I have shared the list as well with the group. Uh, and I hope all of you have joined the Google Classroom as well. Okay, because I will be posting in the attendance there. Okay, so if you haven't joined yet, you could do so. Fine. So before we could get started, I just want to talk about the syllabus. Okay, and for your information, we will be covering about 2 modules in this month. Okay, and we will also be having a quiz, that is quiz 1. Fine. So why I'm telling you all this, so that you all will be mentally ready. Fine. Before we get started, I would like to just show you the syllabus, and then we can move on with our first module. In case you have any doubts, you can feel free to unmute yourself, and you can ask me a question. If not, you have the option to raise hand, or you can also use the chat box, anything which is convenient. Just give me a moment as I pull up uh, the syllabus. The subject code is going to be ECE 733. The subject is very interesting, and the numericals are also very understandable, and the only thing that you have to do is you have to concentrate on my class, and then whatever notes that I pass on, you can refer that. And the textbook that we will be using is going to be Dennis Roddy. Okay, are you all able to see the PDF?
No, sir.
Yes, no?
Visible, sir.
Fine, thank you for the confirmation.
Now it's visible, sir.
Yes, thank you. So this is going to be your syllabus. Okay, satellite communication. It's a 4 credit course. You will have even a self-study component as well. Okay, and self-study component is going to be weightage is 1, and our lecture is going to be 3. Okay, fine. So why do we have to study satellite communication? One of you can unmute and respond. Why is this subject? There should be a purpose, right, when we start off studying a subject. So why is it so? Anand, Anand, maybe you can give me your answer. Yes, sir.
So am I audible?
Yes, go on,
Yes, sir.
go on.
Uh, so basically, satellite communication, it is used in our day-to-day life.
Hmm,
Like since we all watch TV
hmm,
and like the internet that we use and the radios that sometimes in the olden days that we use,
hmm, hmm,
transmitting and stuff. And mostly like it is satellite is basically that connects everything. That
hmm.
connects like us also, and mostly it is used in a military application also.
Exactly.
And like for the huge population, it is like very much useful.
Hmm, hmm. Fine, there
Yeah.
you are. So it's not restricted to just one application. You know, there are n number of uses where we can relate to. Okay, with the use of satellites. It can be, as one of your friend mentioned, as Ruth mentioned. It can be with military purposes as well, right? Communications, entertainment, okay, and all these things. Fine. So the reason why we will be studying, I have just put up here. Okay. So once we finish the course, these are the things that you will be able to. So number one, you'll be able to inspect the fundamentals of communication via satellite. You'll be able to categorize different types of noises, and you'll be able to apply different loss factors in satellite communication. Now, one thing you all should understand is noise is not needed at all, right? Noise is not needed. The reason why noise is not needed is because it disturbs the communication. It eats up the bandwidth, right? The problem isn't solved. So we try to nullify noise as much as possible, and we try to have communication in such a way that it becomes error free. Less noise, the better communication. Fine. Then we will be applying Kepler laws of motion. Okay, I think most of you will be aware with these laws as to how the planetary motion is, and how it actually impacts our satellite. A satellite just cannot be launched at any time or any day. They have to decide as to what time, what weather, and when exactly, how much time it's going to take to reach the destination, how much fuel. There are n number of things that needs to be taken into consideration before you launch a satellite. There are a lot of manual calculations to be done as well, freehand. Then analyzing various satellite orbits and perturbations. So we will be analyzing what kind of orbits, and how are uh, gravitational waves playing an impact with the motion of satellite. Okay, and we'll be able to distinguish between the working of earth element and space element of satellite communication. So one thing that you should understand is satellite communications doesn't happen just with one device, right? You need to have a device at the earth station as well, wherein your earth station will transmit information, and this satellite will act accordingly. So your base station or earth station acts like a remote control, and it controls its motion. Okay, it controls if it has to go to the left or to the right, or if suppose it is out of orbit, we can even place it properly. Okay, so all these are possible with the base station or earth station. So communication, so which means sensors, antennas, waves, the frequency of operation, noise, medium of transmission, all these becomes prime importance. Even when it's raining, the signal is distorted. So there are a lot of challenges that we will be seeing as to how it impacts the communication with respect to satellites. Then we will also examine various satellite services, just like how we spoke about. It could be your satellite phone, or it can be satellites used for communications, right? So it can be satellites in the field of military. Okay, so there are n number of uses which can be explored with this subject. So we will be starting off with module 1, which is fundamentals of satellite and propagation impairments. So you should understand that whenever we launch a satellite, it doesn't mean that it's going to be successful, right? There are a lot of factors involving. So what are these factors? It can be your environment, it can be your weather, it can be the condition of the satellite, it can be the quality of fuel, it can be how uh, your uh, your satellite panels, solar panels, are facing towards the sun, how intense is the sun rays, how far is it from the sun. Okay, uh, then how far is the moon, how is the gravity. So there are I can say n number of factors that needs to be taken into consideration. So having all these set, okay, having all these combinations checked, it's only then it's going to be successful. Okay, so introduction, frequency allocation. We'll be studying about Intelsat and Indian satellite systems. Then in the next second half, we will be studying about the losses, then rain effects, okay, attenuation that can happen just exclusively because of rain, and ionospheric effects. Uh, I'm sure that all of you know that our atmosphere is made up of different layers. So ionosphere is a very important one because that is where many things happens. Okay, communication related things happen. So I will tell you how it impacts waves, how it gets reflected, okay, how it gets bounced back, just because of the combination of these charged particles in the ionosphere. Then in module 2 we'll be discussing about exclusively orbits, loss, Kepler loss, definition, and the orbital element, apogee, perigee, the heights relating to those, then the orbit perturbations, then angle of inclination, with how much angle we should actually tilt the satellite, and how fast it should rotate, revolve. All these things are discussed. Then the types of calendars, then with respect to time, and synchronous orbits. Okay, then we will also be discussing about geostationary orbit, and here we will look about the antenna look angles. Okay, how should your antenna be placed? Remember, previously when we used to have these radios, we used to position it in such a way that we get proper signal. Okay, so that is when the angle of reception comes into picture. Okay, so your antennas should be placed in such a way that it receives maximum signal. The reason why we do it is so that we have proper communication and there isn't going to be any disturbance. Okay, then we'll also be looking into the limits of visibility. Sometimes there are limits for whatever we do. So at certain time, at certain instant of time, the satellite also goes invisible. Okay, because that is beyond our angle angle of look, or we can call it as look angles. Okay, so it becomes invisible. Then earth eclipse of satellite, sun transit outage, so impacts of eclipse, impacts of sun and the moon. Then we'll also be looking into space and space link. Okay, so here we will be having this power supply units, altitude control, how much height that it should cruise through, station keeping, thermal control, very important factor, thermal control, how much temperature should be maintained. I should design my satellite in such a way that, because I'm not keeping the satellite at home, nor am I keeping outside, it's going beyond the planet, it's going in space, right? So you should be ready for any kind of solar flares, solar winds, uh, the heat. It's about 6000 degrees centigrades, the heat that emits from the sun. So all this has to be taken into consideration. Then telemetry, transmission and control subsystem, then transponders, something which can receive and send. Okay, then you have antenna subsystem, space link. Okay, EIRP, you'll be studying this exclusively even in your labs, wireless labs. Okay, EIRP, calculate the EIRP. Okay, then your losses, link power budget. So in order to establish a link, how much power do I need? Then the relating equations, system noise, then your CNR, okay, carrier noise ratio, uplink and downlink, combined CNR. So what should be my uplink frequency? What should be my downlink frequency? How can I change these things? Okay, so all this will be discussed. In the fourth module, we'll be seeing exclusively with the base station. Okay, and how we can utilize this base station. Um, for example, there are different subsections called the outdoor unit, then receive only home TV system, then MATV, CATV, transmission and reception, transmitter and receiver, earth station. So all this will be seen exclusively. At last, we'll be seeing the applications as to where we can use these satellite systems. Okay, so there you go. We will use for navigation, right? Anywhere you want to go from point A to point B, satellite plays a very major role. You don't have to remember the route. Okay, satellite helps you in remembering things, right? So that's the application of satellite, GPS. Okay, then weather forecasting, it helps the farmers, fishery, right? Sending SMS updates to farmers as to when it's going to rain, what is going to be the weather for the next month, when is going to be the cyclone, how long is the cyclone going to last. Okay, so all these are vital information which is necessary for the growth of the country as well as security. Okay, so I think that's about it with regards to your syllabus. Now, what I am going to do is I am going to start off with your module 1. Okay, and fine. Yes, this is what I was talking about. The textbook that you will be using is Dennis Roddy. The single textbook is sufficient for all your 5 modules. For all your 5 modules, the single textbook is very much sufficient. But still, if you wish to take more information, if you want to look into some of the details, then these 3 references I have put up. Okay, so you can make use of them. All these are available in the library. Fine. Okay, so any doubts you have so far, you could ask me. Any questions that you want to ask me with regards to the subject, you could please go ahead. and this is a very scoring subject. Okay, you can really do well in this subject. Block diagrams, explanations, numericals, and you could even expect some straightforward questions sometimes, or uh, just a little bit of data change here and there. Okay, so because these formulas are all standard, okay, you don't derive here, but you will be using those formulas which are already derived. Okay, so that's about the subject. Fine. So we will start off with module 1. My screen is visible, right?
Yes, sir.
Fine, thank you.
Yes, sir.
So this is going to be the fundamentals of satellite. So I have put a few things here as well. Mm, we have discussed this, right? So this is going to be the outcomes and the reference and textbooks. Fine. So this is going to be my agenda for the day. I'm going to discuss a little bit of introduction, what is a satellite, and principles of satellite communication, what are the advantages, uses of satellite, where can we use them, and while using satellite communications, how or what are the merits of having them, then the frequency allocations. Now, one thing you should remember, it cannot operate at all frequencies. There are specific frequencies at which these satellites operate. It's like how you tune into a channel. Similarly, satellites are tuned to a particular frequency, and once it's tuned, you can start sending and receiving information as well as controlling the path of a satellite. There are frequency allocations for different services. Now, the need of space communication. Why do we need space communication? So we have seen this, that we need microwave links. Okay, terrestrial microwave links are not suitable to meet the demand of large geographical coverage for radio, television, networking, and even cellular telephony. So what's happening, if we use just a cell phone for communication, there can be a possibility that your signal breaks down. So you cannot have a wider coverage, cannot have a wider coverage if there is no satellite. The satellite plays a very such important role where it can cover wide area. Okay, it can even cover the whole country and the neighboring countries as well. Okay, fine. So what's a satellite? It's an artificial body placed in an orbit around the Earth or another planet. So the natural satellite is Moon, okay, which revolves around the Earth, and these satellites that we all make are termed artificial because it wasn't available previously. A communication satellite relays around the world telephone and fax messages, television programs, radio signals, and so on. So if I say communication, then there are a lot of things involved, including fax, okay, then TV programs, radio, Okay, so ultimately communications and entertainment and security, these three are important. Okay, so look at the figure here where you can see the satellite. Okay, satellite is here where you can see I have a receiver. Okay, multiple receivers. Then I have a transmitter, which is nothing but called as your base station. It passes through the ionosphere, reaches the satellite, and computations happen there. So which means in satellite you need to have a lot of sensors, okay, a lot of transponders, then solar cells. Sometimes you will need to have fuel because it needs to reach a specified coordinate. And keep in mind, we just cannot place satellite wherever we wish to. Okay, satellites are to be placed at a specific orbit, at a specific coordinate. Okay, so these are receivers where we don't receive signals from base station, but then we receive signals from satellite. Okay, and satellite receives its command from the base station, which is also called your transmitter. Now what are the advantages of using satellite communication? Coverage to a large area, right? So it's just not confined to small area, but then we can actually cover a huge area, sometimes country beyond country. As very large areas of the earth are visible from a satellite, many users can be linked simultaneously who may be widely separated geographically. Even though we might be thousands and thousands of kilometers away, we can all stay connected with the help of satellite. So information is broadcasted with the help of satellite. Satellites form an essential part of communications worldwide, carrying large amounts of data and telephone traffic in addition to TV signals. So there is a lot of research happening with regards to bandwidth. Why is bandwidth so necessary? Because these days uh, most of the communication happens over internet. It can be voice over internet, okay, that is called your voice over internet protocol, or it could be, the best example can be the classes that we are taking up. So it's all based on your internet bandwidth. So bandwidth is one such important role. Those were the days, where previously we used to have a dial-up connection which used to be just about 56 kbps. So with 56 kbps you were only able to check your mails, respond to a mail, probably just Google few sites. Okay, and it was not into rich multimedia. Okay, and then came in your broadband fiber optics, and now researchers have have come up with a research where you can download the whole of Netflix in just 1 second. The whole of Netflix can be downloaded in just 1 second. So you can imagine the amount of speed, the amount of bandwidth, the amount of equipments needed to get this thing going. So communications is one such booming area. Continuing with our advantages, communication to unreachable area, mount, mountain regions, okay, some extreme cliffs where humans cannot reach. That is why we use, the military uses satellite phones, okay, wherein at the time of emergency they will always be connected, okay, because you can never depend on a terrestrial network. Though construction and launch cost is very high, right? Now, this is one such important factor to be considered, which needs extreme support from the government. Okay, so you cannot launch it on your own because the cost is high, and you'll also have to take a lot of permissions from the local governing authority. Okay, so I've given an example where a Canadian satellite, okay, named Anik E1 was $239.2 million, but it is considered cost effective. Just like our Chandrayaan, many people have put up their satellites, but we were able to put it up, okay, at the cost of uh, the movie Gravity. Okay, so it depends on how you utilize your things, how um, economically you plan your budget, and the exact precise calculations. Indians are, keep in mind, Indians are very good at calculations. Okay, uh, especially handwritten calculations, okay, your integration differentiations, and this helps in the precise calculations of launching of satellite. So thereby we normally do not spend huge amounts. Okay, so this is in continuous use, and because it can reach large number of customers. And one more thing that you can remember is, now any satellite that we launch, it doesn't stay there forever. Okay, the best usage would be probably about 15 years. Beyond that, slowly the transponders, the sensors, they start getting degraded, and it's not economical to get back the satellite, or probably to replace them. It's not possible, right? So the only thing that they do is they allow the satellite to die. So how do they do it? They just we use something called maneuvering, the term maneuvering. So using base station, we maneuver the satellite and we make sure that it is in place. So when we stop maneuvering, when we stop keeping in its orbit, it actually hits some other planetary uh, junks, okay, that are present in the space, and then it gets damaged. Okay, so the satellite is allowed to get damaged after the efficient utilization after few number of years. Satellites are also used for remote sensing, like water pollution, checking how much of pollution uh, is present in the water, then about forest, okay, how much of deforestation has happened, and the weather conditions, search and rescue operations for aircrafts that were drowned. So these are some of the frequency allocations that you can look into. Allocating frequency to satellite services is a complicated process which requires international coordination. Now, why do you think we need to go to this ITU, International Telecommunication Union? Because satellite is not confined to a particular country, it's confined to the planet Earth. So if I'm using a particular frequency, a specific frequency, a range of frequency, the other country also shouldn't be using the same. So we all should be in an understanding that who's going to use how much, and what is going to happen, and when the satellite is being launched, and there's a race for even space. It's called the space race, right? So you need your own place, you need to be number one. So you need to have good satellite, you need to have good communication, good bandwidth, less noise, good engineers. Now there are talks going out that they can probably send engineers to replace few parts in the satellite. So which means your job profile is completely going to change. That is going to be in the future, okay, where you will be have to you will be transported, okay, to the space, and say for example you will have to replace a battery or probably a transponder or an antenna, right? That also can be done. So this is the future, okay, may not be possible right now, but in future all this are going to happen. Just like how we visit countries these days, with blink of an eye. We have aeroplanes which can actually take us at the speed of 1200 kilometers an hour, right? So similarly, we can travel from planet to planet in the future. To facilitate frequency planning, the world is divided into three regions. The whole planet is divided into three regions. So R1, R2, and R3. Region 1, 2, and 3. Europe, Africa, and Mongolia. So these three come under one region. North and South America and Greenland. This comes under region 2. Asia, Australia, Southwest Pacific. Okay, all these comes under region 3. With these regions, frequency bands are allocated to various satellite services. Okay, fine. For frequency allocations for satellite services, this can be your question, one of the questions in your internals. What are the frequency allocations for satellite services? So this is going to be your answer: FSS, BSS, MSS, AMSS, LMSS, MMSS, NSS, and meteorological services. Okay, so we will start off with fixed satellite service. So what is FSS? It provides links for existing telephone networks. Okay, now I was mentioning to you about the dial-up connections, right? So networks also need to be upgraded. We had 1G, 2G, 2.5G, right? 3G, 4G, and now the world is gearing up for 5G. So existing telephone networks are to be upgraded, right? As well as for transmitting television signals to cable companies for distribution over cable systems. Now, why do you think your television needs a bandwidth? Can someone respond? Why do we need bandwidth for television? Pranay, why do we need bandwidth for television?
Sir, to receive the signal which is sent
Nowadays,
by
how are televisions? How are televisions these days?
so they are smart televisions.
Yes, so when you say smart televisions, it means that it needs internet, isn't it?
Yes, sir.
Yes.
Yes, sir.
Thank you, Pranay. So these days, televisions are operated in such a way that there's no differentiation between a computer and a television, wherein your television can stream content, right? So when you stream your service providers, it can be your Tata Sky or Airtel or you know any service provider, they will need bandwidth. So how is it possible? Only through satellites. Okay, next, broadcasting satellite service, that is nothing but your BSS. These are intended mainly for direct broadcast. They say direct to home, right? DTH, direct to home. So there's no intermediate thing that comes in. Directly you're receiving signals from the satellite itself, wherein the dish that you have uh, receives signals. And the reason why we do that is so that the quality of transmission is high, there is less noise. Next, with regards to MSS, this refers to networks of communication satellites intended for use with mobile and portable wireless telephones. There are three major types, okay, with respect to mobile satellite services. So the first one is aeronautical, second one is for landlines, then for maritime. What is this maritime? Maritime is nothing but in the sea communications for the ships. Okay, then navigational satellites, this includes your GPS. Okay, search and rescue operations. Then meteorological services, which is nothing but your weather forecasting, right? So frequency is to be allocated to different services. I cannot use the same frequency for all the services. That jumbles up things. So these are very commonly used terms for your transmission. VHF, UHF, very high frequency, ultra high frequency. Okay, then it comes under the L band, S band, C band. The most used for our satellite purpose will be KU band. Okay, KU band is going to be the most used frequency range, which comes under 12 to 18 gigahertz. Okay, this is going to be the frequency of operation for most of the satellites. Okay, then millimeter waves. Okay, which is 110 to 300, and your micrometer. Okay, so this is going to be your just a moment. Yeah, so this will be our last slide. Okay, and I will be continuing in the next class. So for our last discussion, okay, the KU band is one used at present for DBS, okay, digital broadcasting signals, and also for certain FSS. Okay, so what is FSS? Fixed satellite service. Okay, the C band is used for FSS and no DBS is allowed in this band. VHF, very high frequency band, is used for certain mobile and navigational services. So the L band is used for mobile satellite services and navigational systems. So different band for different applications. Okay, so this is what I wanted to discuss in today's class. Tomorrow we will look into Intelsat and some of the evolution that happened with the satellites, and a few more information with regards to Intelsat. So I hope you guys were clear with whatever was discussed today. If any doubts, you can please unmute and you can respond. Any doubts you guys have so far? Are you all able to follow?
Yes, sir.
Fine, fine, Ruth.
Yes, sir.
Thank you. Okay, so what we will do now is we will exit the meeting. Okay, and I will be posting the link for attendance in the classroom. Okay, and you guys can start giving in your attendance. Keep in mind the link will be available only for about 5 minutes. Okay, uh, or I will keep it active till 1:10. Okay, thereafter I will be deactivating it. Okay, fine. Thank you all for joining in. We will meet in the next class.
Thank you, sir.
Thank you, sir.
Welcome.